Hello everyone. We Team Sheet Metal are going to present or discuss something about mechanics of sheet metal forming. So the mechanical properties of a material reflect the relationship between its response to or deformation from an applied load or force. Let us discuss different mechanical properties that are tensile strength, bending strength, compressive strength, yield strength, shear strength, and elastic strength. First of all, bending strength. So it is the maximum stress that the cross section is subjected to when the load is applied between the 2 points of the specimen. Its unit is ampere or Newton per mm square, and it is one of the indexes of material strength. The second one is compressive strength. It is the maximum stress that the sheet metal or material can withstand under pressure without breaking. Its unit is also Newton per mm square or ampere. Thank you.
So now I am going to speak about the remaining three properties, that is yield strength, shear strength, and elastic limit. Yield strength. It refers to the stress of the metal sample during the stretching process when the load no longer increases and the sample continues to deform. Its unit is Newton per mm square or megapascal and symbol is sigma s. The yield strength is the pressure value of the yield point. For the material that is not obvious yield, the stress value that produces 0.2% permanent deformation is often referred to as the yield strength. Next, shear strength. It refers to the maximum load of the original cross-sectional area of the shear area before the sample shears. The unit is Newton per mm square or megapascal and the symbol is sigma t. Elastic limit. It refers to the maximum stress of the specimen under the condition that the test piece deforms after the external force disappears and can recover the original condition. The unit is Newton per mm square or megapascal and the symbol is sigma e. Now I want the rest of the team members to carry forward the presentation.
Thank you, Swapnali. My topic is how material property impacts sheet metal forming, precision, and tolerance. Variation in metal thickness are one of the most common challenges when achieving bending tolerance. Sheet metal can have variation in thickness throughout a single sheet or between sheets. The nature of rolling process often means sheets are thicker in the middle than the edge. The gauge of different sheet metal is usually discussed with respect to average, but in reality the actual thickness can be anywhere within a specific range for category. A very plus or minus 0.0006 in variation material thickness can represent at much 4 degree of angular variation. A very small variation in thickness can impact a bend angle by a few degrees. This has a big impact on result, especially when a tight tolerance are required, because with a air bending, the bend angle is determined by width of die and depth of the punch. A variation in material thickness makes precision more challenging if a narrow die is used. The impact of inconsistent thickness is amplified. Now next to Tapas.
Thank you. Deformation process. Deformation process transforms solid materials from one shape into another. The initial shape is usually simple, example a billet or sheet blank, and is plastically deformed between tools or dies to obtain the desired final geometry and tolerance with required properties. A sequence of such process is generally used to form material progressively from a simple geometry into a complex shapes, whereby the tools represent the desired geometry and impart compressive or tensile stresses to the deforming material through the tool material interface. As illustrated in figures, for the case of extrusion and deep drawing, deformation processes are frequently used in conjunction with other unit operations, such as casting, machining, grinding, and heat treating. To complete the transformation from raw material to finished and assembly ready discrete parts, deformation processes along with machinings have been at core of modern mass production because they have involved primarily metal flow and do not depend on long-term metallurgical rate process. So thank you. Over to next.
Deformation process can be conveniently classified into ball forming process or seed forming process. In both cases, the surface of the deforming material and of the tool are usually in contact, and friction between them has a major influence. In ball forming, the input material is in billet, rod, or slab form, and a considerable increase in the surface to volume ratio occurs in the formed part. In seed forming, a seed blank is plastically deformed into a complex three-dimensional configuration, usually without any significant change in seed thickness and surface characteristics. Now, the characteristics of seed metal forming processes are as follows. The workpiece is a seed or a part fabricated from a seed. The deformation usually causes significant changes in shape but not in cross-section of the seed. In some cases, the magnitudes of permanent plastic and recoverable elastic deformations are comparable. Therefore, elastic recovery or spring back may be significant. Thank you. That's all from our side. Please like, share and subscribe to our YouTube channel. Thank you.